I just wanted to start, I mean, this does follow on from what Eddie was saying in terms of, as MEI works very closely with OCR to develop our A-level. Just firstly to describe who MEI is in case people aren't aware of us. We're an independent maths education charity, but we run things like the Further Maths Support Programme for the Department for Education, and a lot of people know us through our A-level specification that is administered by OCR. Now, what we really wanted to do, MEI, as Eddie has said, has had a strong tradition of having technology or seeing where technology can be used as part of the maths curriculum. And what we really wanted to do was to continue that development work and look at, could we actually do something more in terms of getting technology into the assessment, getting it into the classroom, making it an actual part of what the students are learning and making it part of how the students are assessed. We're aware that, as Eddie has said, a great many students see no more than a standard scientific calculator through the whole of their A-level. We then had to make some quite pragmatic decisions because this wasn't really a talking shop we were interested in. We wanted to get a unit in the A-level specification so we could actually go through all the decisions, see what actually happened when there is a unit that students are using technology in and that they're assessed with, and make some decisions. And a lot of them we had to make quite pragmatic decisions, and what I'll present today is not necessarily a perfect view of what computer-based maths could look like. What it is a unit that exists and students will be taking this year, and that will allow us to inform our future development work. So when we started developing this, in an ideal world, I would have loved to have developed something that would have taken the current maths curriculum and looked at how using technology could help students understand that content better. We were advised from quite early on that wouldn't be approved by the regulators, and that the regulators, if we wanted to submit a new unit, it had to have new mathematical content. So you'll see in a minute when I show the mathematical content, it by definition has to be above and beyond what students are currently studying in A-level maths and A-level further maths. The other decision we made, and it's very closely tied into this session because it's to do with the assessment, is that the thinking about how students might use technology and how that can be assessed, we thought, and I will stick with the current pure and applied split the way that A-level's talked about for now, that if we tried to do something in applied maths, we realised very quickly that would probably need a very different form of assessment than something that was looking at the use of technology in what's currently described as pure maths. It's not that MEI isn't keen to really develop the use of technology for students looking at real-world problems and solving real-world problems. It's just that this wasn't the place to do it. I expect many of you have seen the education news on Wednesday, and it's very exciting that in parallel to this, MEI is starting some development work that's specifically going to be aimed at students who pass GCSE maths but don't go on to A-level, and looking at a course that's appropriate for those students. And that will have a very strong technology component to it. If you've seen it, there's some very interesting ideas on Tim Gower's blog about what these sort of problems could look like. And hopefully you'll see very soon, and possibly at a future conference, somebody from MEI talking about exactly what we're doing in terms of a course based on students using technology to solve real-world problems. However, as I say, that's not what this specifically is. What we have ended up developing is a unit that exists in the current further pure maths specification. So, for those of you who are not familiar with A-levels, this is the 13,000 students that Eddie was talking about a moment ago. There's 85,000 students who study A-level, and then there's a further 13,000 who take further maths. This is those students who take further maths. They take possibly 12 units. Some of them even take 15 units, and this will be one of those 12 or 15 units. OCR have been incredibly supportive, and this really has been a joint development with them, as it has to be, as it's on the specification is administered by them. And we're also very grateful for Texas Instruments, who've been really supportive in all the work we've been doing. as I say, the impetus here was to actually get something on the curriculum that real teachers were teaching, that real students were taking, so we could see how that worked, what does work in the classroom, what does work in the assessment, what doesn't work, as opposed to just thinking in terms of ideas, to actually get something in practice and see what the impact of that was. But the great news is that this has been approved by the regulator. There will be students studying it from January, there will be students teachers teaching it from January, and there will be students taking the exam this summer. So some students this summer will be taking a further maths A level where one of their units is a computer-based further maths unit. So in terms of the technology, what does it look like? Well, we were very keen that it really focused on, we identified these as the 4 main applications that we would really want students to be using in their study of maths, which was a graph plotter, spreadsheet, computer algebra system, and a programming language. One of the pragmatic decisions we had to take quite early on was whether we would specify a certain piece of software, whether it would be open, students could use any software. Would we develop parallel teaching and learning resources in one piece of software and another piece of software? The route we've gone down is that we've said that the teaching and learning resources and the examination will be written using TI Inspire, because it's a great piece of software. It's got all of these aspects, plus it is accessible to schools, and many schools are very used to using it. However, that won't be completely exclusive, and one of the mechanisms will be that centres will be able to inform OCR of the software that they're using, and that will either be approved or not. So we've taken that decision that we didn't want to specify a piece of software, but it felt very natural to say that there is one piece of software that the teaching and learning resources, the professional development for the teachers, and is used when the exam is set, is a consistent approach, and it gives a lot of guidance to schools, I think. It's by no means saying, though, that it's exclusive. In terms of the content, as I say, we were advised that the content had to be content that wasn't currently in the A-level maths or A-level further maths specification, so it had to be new content. Well, there were lots of units and lots of options in maths and further maths, so it was a very interesting activity to sit through and go through the whole of further maths and think, right, what's actually not in there that's appropriate for students and can be tackled with technology. We've ended up with 3 topics, which are investigations of curves, looking at what happens when there's a parameter in a curve, functions of complex variables, what happens if with the functions that students generally meet at this level, what happens if the input to those functions is a complex number, and then some number theory, which can be tackled with programming. There's an example of the questions here, and I think the common theme with all of these, and this is exactly why we think these are really appropriate to a computer-based unit, is that for all of them, they're maths that you could approach without technology. However, what technology allows you to do in all of these cases is get a lot of results very quickly that then you can do your analysis on. And if there's a theme, I would say it's that I mean, the last one there's a great example of that you wouldn't want to test all the cases of X and Y up to 100, but you can get a computer to very quickly churn out which are the solutions by testing all those cases very quickly. You can then do some analysis based on those results. So if there is a theme to this unit, I would say, although the content looks very discrete, it's that it's areas of maths where you can get a lot of results very quickly with the technology, and then you can think about what those results mean. You can do some analysis of what's come out of those results. So, and this session obviously is about assessment, and we were very aware of just how much a driver assessment is in terms of what happens in the classroom. That paper's not put up there as an example of something that you're expected to read. It's put up there to show you that what the assessment will look like is that the assessment will look like a normal, traditional, if you like, mathematics paper. It will be a written paper, and it will be a paper whereby, with all of the questions, it will be assumed that students have a computer with the software in front of them on the desk, and that they can't really get started on these questions until they've done something on the computer. However, the submission is going to be paper-based. Now, we went around the houses a lot on this and tried to decide what the appropriateness might have been of having some files for the students to work with beforehand, whether we could have taken some electronic submission of files from students. All of those, I think, are very valid things to want to do. They're very valid things to see how they work. As I say, many of the decisions we've taken on this are, we just wanted to get something on the specifications. We wanted to get something approved. We wanted to get something that could work in practice that could then inform future development work. There's actually nothing that we've written into the specification that would mean that if in future years we wanted to take electronic submission of files from students, that wouldn't be possible. It's just in the first year we're going for something that we know will work in terms of the current assessment structure, and also we wanted something that would appeal to schools, because there would have been no point writing something that no schools felt that it was feasible for them to teach their students. And there's a lot of practical decisions schools are going to have to make in terms of how they set up the teaching and learning, and how they set up the exam hall when they're doing the exam. Which leads me on to our engagement with schools. I mean, MEI is an organisation that grew out of a teachers group. It's an organisation that has strong links with teachers, and I think we would strongly argue that good curriculum development has to involve teachers and teachers' real experiences with students at every possible stage, and to get some feedback on that. So we're very pleased that at the moment we've got 11 schools and maybe one or two more, but we've got 11 schools who are going to be working on this in the first year. There are going to be about 50 students taking the exam this summer. And as I say, we're very keen to work with these teachers and support them throughout their development, and get their feedback in terms of what the teaching and learning resources look like. What happens when they implement this in the classroom? Does it actually work when the students start studying in this way? And really collect some information on that. And the last point there really is to say that this clearly isn't a wholesale computer-based further maths A-level of 12 units where everything's computer-based. It's one small unit. One thing that we'll be very interested in terms of an incremental approach to introducing computer-based maths, is whether if you have an aspect that's computer-based, what's the impact then on the rest of their teaching and learning? So I just want to finish really. I do have copies of the specification and the specimen paper. They're on our website as well, but I have paper copies with me today if anyone wants to look at those questions and see how we've implemented it in more detail. Just really wanted to finish with 2 points. The first of them is this idea that was just mentioned in terms of an incremental approach, that I think that it is possible to work within the current framework and look at small approaches and see how they work, get feedback from teachers and students, and use that as small steps towards the way we would eventually want to go. The other thing I think is worth addressing is that whilst there are great opportunities for using computer-based maths for analysing real-world problems, there's also a massive opportunity for using computer-based maths to improve and enhance students' understanding of maths itself, those relationships between the abstract objects. So I think that pure and applied split, I don't think we really see it. We just see parallel developments that can support increasing the use of technology in both of those areas. But I shall finish there. As I say, if anybody wants to see the papers, I've got paper copies with me. They're also on MEI's website, and my contact details are there as well. Thank you.